Swayam Prabha. Digital India. Educated India.
Hello all, welcome to the basic microeconomics course again. This is Dr. Angan Singh Gupta. I welcome you all on behalf of Swayam Prabha Channel 15. I wish that you all are doing well. And so today is our 7th lecture where we will be discussing about long run production function. So in the last day we started discussing about theory of forms and theory of production, and we discussed about short-run production function, where we had discussed about when one particular output changes, how one particular input factors of production changes, how does production change. We also discussed about production function and what is short run and what is long run production function, and what is marginal productivity, average productivity, the relationship between total productivity, marginal productivity, and average productivity. And then we discussed about why what is diminishing marginal returns, law of diminishing marginal returns. So today we will discuss about the long run production function, which is essentially allow us to change all the factors of production or the quantities being used of all the factors of production in a given time period. So if you remember, the short-run production function was a condition where you cannot change all the factors of production. At least one will remain as fixed input in a two input production process. We have seen that if it is a labor and capital, either of labor or capital remains fixed, and that is how our output changes, because we cannot change both in two factors of production, labor and capital. At least one has to be fixed in short run and the other one is capital. And we did a small example of estimation of marginal product and average product, where we saw that how our total product is changing when the capital has remained fixed in 10, 10, 10, 10, 10, and our labor input is changing from 0, 1, 2, 3, 4, 5, 6, 7, and so on, and how our total output is changing. Now the marginal product is the rate of change, whereas the average product is total output divided by total number of factors of production, that particular factor of production input. Average product for labor is total output divided by total number of labor, where marginal product is change in total output divided by change in 1 unit extra labor recruitment or enforcement. So if I increase 1 unit of labor, how much output changes? What is the quantity of output changes? That is known as marginal productivity of labor. The same is marginal productivity of capital with respect to changing 1 extra unit of capital, and how much the output changes. And we have seen that it first increases and then starts decreasing, and then it goes to negative. When it touches 0, the total product reaches maximum. When marginal product goes to negative, average product cannot go to negative, because total product divided by total labor or total capital, total product is always more than 0. It cannot be negative, so average product cannot be negative. But marginal product, the change, the incremental rate, what every unit of labor or capital is contributing, that marginal product, that contribution can be negative, and hence marginal product goes back to can go to negative. And when marginal product goes to negative, that means the total product, instead of increasing, when I include 1 extra labor or capital, instead of increasing, total product goes decreasing. right? And then the total product after reaching maximum, it falls down when marginal product reaches to 0 and then further to negative. So this is in a nutshell what we have discussed in our previous class. We will be discussing about long run production function today in this lecture, where we will change both the factors of production, both the inputs. Yes, we will start with a Cobb-Douglas production function, which was deducted by Professor Paul Douglas and mathematician Charles Cobb, together based on some empirical data. And here, we have seen that quantity of output Q is a function of labor and capital L and K. And then there were certain other factors of production, like say technology, organization, so on and so forth. But here we are discussing L and K, where L is labor and K is capital. So it's a linear homogeneous production function of degree at which two inputs contribute to the production process, producing a certain amount of output. Now, a Cobb-Douglas production function Q equals L to the power alpha K to the power beta, where alpha and beta represents, see, alpha is with L, beta is with K. Alpha and beta represents output elasticity of labor and capital respectively. All these A, the values of A, alpha and beta should be greater than 0, and they are less than 1 mostly. Now, alpha and beta, that means the elasticity, output elasticity between, for labor and capital in an ideal condition, assumed to be equaling 1, right? Alpha plus beta equals 1. So over here, L to the power alpha, K to the power beta, instead of beta, we can also write K to the power 1 minus alpha, because beta is nothing but 1 minus alpha. So we can write Q equals L to the power alpha, K to the power 1 minus alpha, but not on all the conditions that we will learn later, today itself, but probably the last slide. So what is this output elasticity? If you remember what is demand elasticity, that means with a price elasticity of demand, that is like how much, or elasticity of demand. This output elasticity is nothing but the elasticity of output. So elasticity of demand, or demand elasticity, was nothing but how much quantity of demand changes when price rises by 1 unit. So similarly, output elasticity is how much total output Q changes with the rise in 1 unit of, labor or capital input. So quantity of demand that changes with price. If you remember income elasticity of demand, quantity of demand that changes with income. So similarly over here, output elasticity is quantity of output when it is changing with the labor and capital employed in that production process. So it is the responsiveness of output to a change in levels of either labor and capital. So coming back over here again, if we see that Y, so these are the certain properties, that Y equals total production. It is the real value of all goods and services produced in a particular year. L is labor input. You can estimate it in terms of person hours they have worked in a particular year. In that particular year, K is the capital input. It considers all machinery, equipment, buildings, etc. And A is known as the total factor productivity. So the total factor productivity is anything associated, anything beyond the labor and capital, often considered as technology along with the labor and capital. So this is known as total factor productivity. That A is this, this A to the power A, L to the power alpha, K to the power beta. This A remains fixed. Yes. So this is about the Cobb-Douglas production function. We can estimate the marginal productivity of labor and marginal productivity of capital if you remember a bit of differentiation, or if you have ever gone through, so this is nothing but delta Q by delta A, change in output with respect to 1 unit change in labor input, delta Q by delta L, equals this alpha AL to the power alpha. This comes in front, so it becomes alpha into A L to the power alpha minus 1. So this is how we do it. The same thing happens with beta, k to the power beta. If we are doing delta Q by delta K, that beta comes in front, and k beta k to the power beta minus 1. You can look at it if you are finding interest in this, differential calculus and all. But otherwise, with this also we can estimate the marginal productivity of labor and capital, and with that is the change in output with respect to 1 unit change in labor and capital. So what is production with two variables in long run is when the relationship between production and productivity, we look at the relationship between production and productivity, keeping both labor and capital variable input. So you can change the quantity of capital and labor anytime you want. If there is a sudden demand, you can change both the capital and labor. That is long run. If you cannot change the labor but you can change capital, or if you cannot change the capital and you can change labor, then that remains a short run period for that particular production process, right? So how do we estimate, or how do I say, as we have studied in indifference curve, that in indifference curve, what do we get? In indifference curve, we get equal amount of satisfaction. Now, what is that equal amount of satisfaction? That equal amount of satisfaction which we get through the consumption of different combination of two outputs. So indifference curve gives me the points on indifference curve, that gives me all these different combinations of apples and oranges, rasgulla and gulab jamun, all different combinations, which gives me equal satisfaction. So similarly, Isoquant gives me all different combinations of capital and labor, which gives me a particular output. And that output on a particular isoquant remains fixed. That particular output on a particular isoquant remains fixed. Now, what is isoquant? Iso is same and quant is quantities. Same as indifference curve, where we looked at indifference curve is where every individual consumer, or where an individual is indifferent in terms of choices given in that indifference curve. That whatever combination you give, 4 apples 1 orange, 1 apple 4 orange, 3 apples 2 orange, 2 apples 3 orange. So whatever combination you give, that gives me equal amount of satisfaction. The same thing happens here in case of isoquant. Whatever combination of capital and labor you give, if those combinations are producing the same amount of quantity, iso is same, quant is quantity, then that will be my isoquant. In long run, again, as I said, both of the factor of production are changing and experience a diminishing return. Now again, I will connect with indifference curve, that why that indifference curve were convex to the origin, because the utility used to decline with more and more production of a particular good or commodity. So when you consume more and more, what happens? Your marginal utility declines. So that is diminishing marginal utility, right? So what we discuss in theory of production, diminishing marginal return. So keeping one factor same, if you recruit another factor more and more, the output generation by each and every addition becomes lower and lower. Too many cook, spoil the food, right? So if I have a lot of mangoes, my the satisfaction I get from those mangoes slowly decline. Similarly, If I have too many laborers, then probably there will be the union problem, the motivation problem, fights and politics. So maybe the output will not increase much due to inefficiency, and that is explained. So isoquant is often explained by these diminishing returns, and that is how again an isoquant is convex to the origin. Yes, convex to the origin. These are the isoquants. You can see at one side we have this capital per year on the y-axis. On the x-axis we have labor per year. So we can observe over here that isoquants are downward sloping and they are convex like the indifference curves we have studied in consumer behavior. Now, when it's always fixed again, the mostly we keep the labor on the x-axis, capital K in the y-axis, labor L in the x-axis, capital K in the y-axis. You don't need to write labor per year or capital per year. You can just write L and K, and you can just L or slash and then YR, K slash YR. That also you can do to save time, because L and K is the labor and capital almost globally accepted. Now, what are these isoquants are stating? So these isoquants are stating that if you see that Q1, if you see here that brown color isoquant Q1 is showing that in under Q1, all these different combinations of labor and capital will produce 55 units of outputs. In Q2, they will produce 75 units of output, whereas in Q3, they will produce 90 units of outputs. And of course, the labor and capital composition is changing. That is where the production is increasing. It's same as we have studied more is better in our consumer behavior, that when keeping one particular commodity same, I increase the consumption of the other commodity, more is better. And if I 5 apple and 5 oranges, as compared to that, if I have 8 apples and 5 oranges, I will be happier, right? And I move to a higher indifference curve when I am happier. So the same thing happens here with 1 labor and 3 capital. That farm, that particular production unit produces 55 units of quantity of production. Whereas if I increase 1 extra unit of labor, so the labor number moves from 1 to 2, and the capital remains fixed at 3, and the production increases to 75. The third one is labor I increase to now number 3, the capital remaining fixed at 3 units, and hence again I have increased the labor with the same amount of capital. My quantity is certainly bound to increase. Mostly as of now, our marginal productivity of labor, we assume, is not a negative side. But so what we observe, again, as I said, marginal productivity is not on the negative side. That means total productivity is not falling. And hence, when I am increasing 1 extra unit of labor, then we observe that the total quantity of production has moved to 75 to 90. So what we can observe from this diminishing marginal rate of substitution, often known as technical substitution, what we know from these, that when our production increases from, we have say 3 labors, and capital increase from 0 to 1, we have 3 labors, and capital increases from 0 to 1, and sorry, over here first we discussed that we have 3 capital and labor increases from 0 to 1, 1 to 2, 1 to 3, and our quantity of production has increased from 55 to 75 and 75 to 90. So when keeping these 3 capital fixed as 3 units, I have increased my labor force from 1 to 2 and from 2 to 3. Let us assume from 0 to 1, 1 to 2, and 2 to 3. Now, when I have 0 labor and no capital, I don't have any production. And then I increase 1 extra capital. So 0 labor and 3 capital, I have no production. Now I have increased or included 1 labor. 1 labor, 3 capital. How many I am producing? 55. Yes. So total output increases from 0 to 55. So the change in output is 55 minus 0 equals 55. Whereas change in labor is, earlier there were 0 labor, now we have 1 labor. So always from the recent one to the previous one, so 1 minus 0. So on the denominator upper it is 55 minus 0, niche on the numerator it is 55 minus 0, on the denominator niche it is 1 minus 0. So 55 divided by 1, so the change is 55. Yes, so the same thing we observe when we are discussing an increase in the labor force further, keeping the capital same at 3. And we have observed now my output with 1 additional input, my output increases from 55 to 75. That means my output has increased by 20 units. The next one, my production increases from 75 to 90, that is 90 minus 75 equals 15. But keeping the capital same at 3, my labor has increased from 2 to 3. So that means with 1 extra unit of labor, my marginal product now is 90 minus 75, 15. So initially my marginal product of labor was 55 minus 0 with 3 capital. Okay, 55 minus 0, 55. The next one is when 2 minus 1, then 75 minus 55, the capital quantity of production increases by 20 units. I include another labor from 2 to 3, and I see my output has increased from 75 to 90, that is 15. Now how it has changed? First 55, then 20, and then 15. What is changing? The returns, the marginal product, the returns I am getting from the output. So from the labor, so the returns is the output. So with every additional labor, how much return I am getting. So this is diminishing marginal return, where the marginal return, the output, additional output I am getting from extra unit of labors for each and every recruitment, that is gradually decreasing. So that is known as diminishing marginal rate of substitution. All right, so we are substituting capital and labor. We can, so the same thing you can observe, if labor is fixed at 3 and then the capital increases from 0 to 1, 1 to 2, and 1 to 3, and the the output increases at a decreasing rate, 55, 20, and 15. So what is the substituting among inputs? The substituting among inputs is nothing but when the managers want to determine what combination of inputs to use. They have both labor and capital, so they can shuffle 3 labor 2 capital, 2 labor 3 capital, 1 labor 4 capital, 5 labor 0 capital if possible, or 4 capital 1 labor. So they always have different combinations, like we have different combinations of commodities. Here we have different in theories of firm or production, we have different combinations of labor and capital. All right, So the slope of this isoquant is given by how this labor and capital are being exchanged. Yes, substituted for each other, and our attempt will be to try to keep the quantity of production same, because if we can keep the quantity of production same, then only we can estimate the substitutability between labor and capital. How do we measure that? If you remember, we used to measure as the marginal utility of X and Y and all. So here we are measuring in terms of the change in capital and change in labor. So as again manager would like to use different combinations of inputs. So now we have just two inputs, capital and labor. We will try to understand that what will be the substitutability between capital and labor, and this is known as marginal rate of technical. The previous was marginal rate of substitution. This is marginal rate of technical substitution, because we are employing this concept of changing capital and labor in a production process, which is of course a technical subject, which is a technical issue, and hence probably the engineer or the business person or the entrepreneur, whoever, so they would have an understanding between how capital and labor will change, keeping the quantity of production being same, but the economists will say that given a certain budget whether it makes sense or not. So let us see. Minus, why minus? Because for a particular level of quantity, if we are trying to keep the quantity same, so when I am increasing labor, I need to sacrifice capital. Otherwise, if capital I keep similar, I just increase the labor, I will move to the next isoquants, right? If I need to stay on the same isoquant, producing the same quantity of production, then I must need to substitute labor and capital. That means if I am recruiting more of labor, I need to give up certain capital. The same thing is happening if I am recruiting more of capital. I also need to give a certain number of labors, right? So this is how we generally measure the substitutability between capital and labor. And again, you see that capital on the y-axis, labor in the l-axis. And when I move from 5 to 2, and we are on the Q2 75 now. So initially we had 5 capital and 1 labor force, and now if we are moving from the first this point to this point, if we are moving from this point to this point, yes, if I recruit 1 extra unit of labor, how much I am sacrificing capital? 3 units, 2 units. So when I am recruiting 1 labor extra, I am sacrificing 2 unit of capital. The same thing happens from 2 to 3. I am recruiting, look at this, the screen. I am recruiting 1 labor, but my capital number reduces from 3 to 2, right? Earlier, I released 2 capitals just to have 1 extra unit of labor. Immediately, if I want to have 3 labors, now I am leaving only 1 capital. Now I want another labor from 3 to 4. Now you can see over here how many capitals I am sacrificing? 2 by 3. And I move further from 3 to 4. So every time my labor is increasing by 1 unit, 1 unit, 1 unit. But the demand for capital, when we have more and more labor, generally decreases. And we have observed that from 4 to 5, when we have increased 1 extra unit of labor, our capital only falls by 1/3 of its capacity. There, so when I have over here, I have very less amount of capital, so my demand, or the way I value capital, that is increased, and naturally my willingness to sacrifice capital will decline, will be lower as compared to when I was in the very beginning, when I was desperate to get certain labors, because now over here I have too many labors, right? I have too many labors, but I don't want them. I want, sorry, too many of capital, but I want labor. So when I move from 1 to 2, I'm okay to sacrifice, say, 2 units of capital, because we desperately want labors. And even if I let go capital, that probably won't make much of an impact. Now, which are these isoquants? Where or how do they look like, these isoquants, when they are perfectly substitutable? So just take an example. They are straight line, and at point A, I have certain amount of capital and labor. At point B, I have certain amount of capital and labor, and point C, certain amount of capital and labor. Now, what we observe when we move from A to B, of course the composition is changing, and further from B to C. But you observe that the way I am replacing my labor or my capital, that is remaining fixed. That is not changing at all, because the slope has remained fixed. So in a perfectly substitutable commodity, when I have substitutable factors of production, when I can easily replace labor to capital or capital for labor, then I generally get a downward sloping straight line, because the amount I am sacrificing over here, if this is 1, the amount I am sacrificing is much lesser, uh, and it follows the same. So, but it is now, if it is convex, it will go down. But if it is a perfectly substitutable, it will not go down. Rather, it will that is why it is downward sloping. It will certainly go down, because you need to replace by another one, and hence we have observed that the isoquants are downward sloping. But in a perfectly substitutable factors of production case, we will have a straight line where the labor and capital, if you remember how we were changing delta L by delta K, is the slope for the isoquant. So over here the slope is fixed, because we are replacing the same amount of capital every time with 1 extra unit of labor. So if I have 1 extra unit of labor, I give 1 capital. 2 extra unit, another extra unit of labor, I will give another capital. So if labor and capital, labor, so a car and a driver. So if this is perfectly, or it's probably a complementary example, it's not the right example. But if I have, say, um, producing something where I can replace labor with the capital, they probably a robot and a human being, then I will get this kind of straight lines. What we observe in case of fixed proportion production function, this is nothing but the complementary production function. We find an L-shaped or right angle shaped isoquant, where the example I took about the car and the driver, yeah, over here, say 1 car, 1 driver. Over here, 2 cars, 2 drivers. Over here, 3 cars, 3 drivers. And now if I have, this is my car, and I have 5 drivers over here, but I have 1 car. How many cars will travel? Only 1. It's the same example which we discussed in our indifference curve. The same thing happens if I am having one, capital, one labor, and now over here I have 2 capital, 3 capital, 4 capital, and 1 labor. 2 cars, 3 cars, 4 cars, but 1 driver. How many car can travel? Only one. So the same thing over here happens if it is a perfectly complementary. So beyond a certain combination, you increase any of the other one, it does not really matter. Like say, if I have 1 pair of shoes, it is fine. I have 5 of left and 1 of right, I can just use that one. Similarly, if I have 6 of left and 2 of right, I can just use 2 pairs, not more than that. And hence these perfectly complementary production functions, or we also call fixed proportions production function, where the proportion of labor and capital will remain same, like say over here, and then over here, and then over here, and then if you want to measure the distance, they are equidistant often, and will be often equidistant, not always. We'll discuss about that shortly, and they will be considered as isoquant for perfectly complementary products. Perfectly complementary inputs or factors of production. Right, now we will discuss about returns to scale. What is returns to scale? Our returns to scale is when we measure the scale of production, that is the amount of the scales of production, that is the total number of labor and capital we have recruited, and its impact on the total output. Now, there are 3 types of returns to scale: increasing return to scale, decreasing return to scale, and constant return to scale. Increasing, decreasing, and constant. What is increasing return to scale? Again, that is, the previous one was diminishing marginal return. What is return? Return is output with respect to capital or labor. And what is marginal? Marginal is the change in the output with 1 extra unit of capital or labor. Over here, it is return to scale. Try to identify the difference. Return to scale. Now, what is scale? Scale is its capacity, size of that particular industry or firm while it is producing or manufacturing something. So same here, when we discuss about scale, we generally try to understand its overall capacity. And over here you can see that with for the production function, Q equals 50 is a function of when we are recruiting 10 labor and 10 capital. All right, now let us understand what happens for increasing return to scale. For increasing return to scale, we observe that with 10 labor and 10 capital, my total output is 50 units. If I multiply my labor and capital by 2 times, so I just increase the scale of my production, the capacity of my production, the total number of inputs or factors of production working there is multiplied by 2, I expect it may also rise by 2 times. If with the labor and capital being doubled, my output increases more than 2 times. Wonderful, right? It happens. So if my labor and capital increases by 2 times, so if you see 10 labor to 20 labor, 10 capital to 20 capital. But how much my quantity of production has increased? 50 to 150. So my labor and capital has increased by 2 times and my output has increased by 3 times. And hence, this is known as increasing returns to scale. When does it happen? When larger output is associated with lower cost. All right, so in the automobile industry and all, we often see that the cost is low but the output is much bigger. The cost of factors of production is low. So when you increase your scalability, when you recruit more of a labor and capital, because the every labor and capital when recruited, they are potentially can contribute more. And if it is like the marginal product is on the increasing side and your total product increases for a long duration, then this is just at a long run, the more the output is, you gain an opportunity, you gain the market share. All right, and you can keep it in a lower cost. The second is, one firm is more efficient than many others. How do we consider that? It can happen that in a particular firm, whatever labor and capital is working, so they are technologically, if not technologically, by their quality of their input, the quality of their labor, the skill they have, all are very advanced. And hence, we have seen that even if the labor and capital is increased by 2 times, the output increases by 3 times. And over here, what we observe, that the isoquants get close together. Let's see. Over here, you see this particular distance is wider, larger than this particular distance. So what it means? It means that if my output, my input has increased from 5 to 10 for labor and 2 to 4 for capital, my iso quant shifts from 20 to 20. Then it is constant return to scale. Yes, I'll come to that. So, but instead of increasing my labor and capital 2 times, I observe that those who are, whatever was being produced is Q equals 10 with 2 capital and 5 labor should be multiplied to 20. I mean, multiplied by 2 to 20. So now when I have 4 capital and 10 labors, instead of 20, if you combine 4 capital and 10 labors, my isoquant 30 is here. So this 20 should have been over here. This 20 should have been over here. Instead of over here, this is 30, and we have an isoquant, the 20 isoquant. For 20 isoquant, I will require lesser amount of labor and capital, probably 8 labor and 3.5 capital, something like that. Yes, so when at this point we should get 20 outputs, we are getting 30 outputs. So the isoquants are getting closer to each other. Constant return to scale, very easy to understand. I have 10 labors and 10 capital. I multiply them multiply them by 2, and hence my quantity of production should increase from 50 to 100. And and if we observe that when we are increasing our labor and capital by the same amount, or by a particular amount, we are increasing our labor and capital by a particular amount, we observe that my quantity of production is increasing by the same proportion. So the labor and capital increases from 10 to 20, 10 to 20, and my output has increased exactly 50 to 100, unlike the previous case, right? So why this happens? The number one cause is size does not affect productivity. We have seen a larger long business industries, where there are a lot of people working, and it has a large size, and but at the same time the productivity may not increase, or whatever the technology, whatever the size, it it does not really matter in terms of the output it is producing. So if you increase the labor and capital by a certain amount, the production also increases by the same amount. Yes, it can happen when we have a large number of producers in small fragments. So they are all, when they are operating at a smaller level, so they can achieve that constant return to scale, if not increasing return to scale. And what here we observe that the isoquants are equidistant, the same distance, right? Over here you can see the distance has remained same, so the same distance. So 5 2 capital 5 labor, I am producing 10. 4 capital 10 labor, I am producing 20. And then for the 6 capital and 15 letters labors, I am producing 30 units. So every time I am increasing my labor and capital, both of them by two times, and I see that the isoquants are moving exactly by the same pattern. Yes, and hence this is known as constant returns to scale. The last one is decreasing return to scale. And I think you now understand what is decreasing return to scale. This is nothing but when the output rises less than 2 times, even if you have increased your output by 2 times. So we have seen that labor and capital in the slide. We can see that the labor and capital has increased by 2 times and 2 times, whereas the output, the production, should have got increased to 50 to 100. But how much it has increased? It has increased only by 1.5 times. It has reached 75. So the labor and capital has increased twice, but the output has increased by less than 2 times, here 1.5 times. Then that is known as decreasing return to scale. Yes, so there can be several reasons again. So it can be decreasing efficiency with large size. I told you that too many cooks spoil the food. There can be a small industry or a large industry where I have taken labors beyond it is really needed or beyond it is optimal. Then I will see that, I will observe where there are decreasing return or not, that if any additional labor or capital is actually decreasing the production or not. If it is not decreasing, well and good. If it is, the production is not decreasing, the rate at which the production is increasing, that elasticity, that is decreasing. And hence, if you are considering these points, that the and reduction of entrepreneurial abilities, because I can start a new business, I may not be extremely efficient, and then I will have to, whatever I will produce, that will be lesser in quantity, as unlike I was expecting otherwise, right? So this happens when we generally in a particular industry, it can be just 2 persons industry, 5% industry, it can be 50,000 persons industry. So it all matters how you manage within. So it's a decreasing efficiency with large size may happen, where we can find a decreasing return to scale. It can happen on under inefficient managers, or those who have um, limited entrepreneur ability, who can raise questions, and hence transform their production to the next level, and that does not happen. And hence we observe that the isoquants move further beyond. And what we observe, that instead of over here, so with 2 capital and 5 labor, I am producing 10 units. Yes, whereas with 8 capitals and 20 labors, right? So initially I was producing with 2 capital and 5 labor. Right now I am producing with 8 capital and 20 labor. By how many times my production has labor and capital has increased? 4 times. What we observe, instead of, now if we combine 8 and 20 together, instead of 40 isoquant, jumping from 10 to 40. So if labor increases by 4 times, capital increases by 4 times, so the output should also increase by 4 times, so 10 to 40. Yes, and we have observed that it is not going to 40. Even if we are just multiplying the labor and capital by 4 units, our output has only reached to 30. Yes, so so 30 should have been somewhere here. Now we observe 30 is associated with the 4 times labor and capital because inefficiency of someone or the management or the employee or certain other factors, and hence the now 40 will be somewhere here. Yes, and hence there is a distance between the between the isoquants under decreasing return to scale. All right. So if we go back to the Cobb-Douglas production function, we can again, as we say that alpha plus beta, they are output elasticities. If they equate to 1, alpha for labor and beta for capital, they are output elasticities, and nothing but you will they are nothing but the coefficients. And so what we observe, they need to add to 1 for a constant return to scale. For an increasing return to scale, this output elasticity. So if you increase labor or capital, the output, how much it increases in an elastic condition, it will increase further, it will increase more. So it is nothing but the increasing return to scale, because you are increasing by 2 times, it is increasing by 3 times. So it is elastic, right? So the same thing happens if I increase my price by 2 times or fall my price by 50%, and I see a 70% rise in the demand of my commodity. So naturally there is an elasticity. So in case of elasticity, the resultant factor, the output here increases more than the rise in the inputs. So naturally that alpha and beta together, when it is an output elasticity, will be greater than 1. For decreasing return to scale, same thing, alpha and beta, even if they are increased by 5 times, the production does not increase by 5 times, rather it increases by 4 times, it can increase by 4.5 times, it can increase by 4.9 times, just taking an example, will be the reason for a decreasing return to scale, where the even if after increasing the inputs, the output does not give us a satisfactory return. So, and alpha plus beta, the elasticities will be smaller, and hence they do not add to 1. Yes, and the capital output elasticity of capital does not compensate to output elasticity of labor. It can, but if it is alpha plus beta less than 1, they are not. Yeah. So otherwise, it can very well complement each other. Here we will discuss about the equilibrium of the of a producer, how they identify the best possible combination of capital and labor, and and how to achieve the maximum production. Now they have a constraint. The constraint is again their budget. If you remember in our indifference curve and budget line, they used to be tangent with each other, going back to the consumer behavior class. And there we used to find the maximum satisfaction that that consumer will derive out of a particular combination of two commodities given a particular budget or their income, right? So given an income, where and how much they will consume of both the commodities, goods or services, to achieve the highest satisfaction. So here the satisfaction from the consumer, now here it is production for the producer, the output, quantity of output produced for the producer. So they will try to maximize this quantity of output with the combination of capital and labor, and given the constraint, which is the budget line. This budget over here is known as ISO cost curve. ISO means same cost. So on that particular straight line, all these points will bear the same cost. But on those points on that budget line, they will give different combinations of capital and labor, yes, given their prices, that is PK for capital, PL for labor, they will be spending this much of cost. So the cost, like the budget equation, the budget function, the cost iso cost or the cost function over here is, or the budgeted cost outlay, whatever you say, is given is PK into the amount of capital, price of capital into the amount of capital, plus price of labor into the amount of labor. The equation can be written differently, and we see here that we can find that total capital being used is cost divided by the price of capital minus PL by PK, that price of labor by price of capital into the labor. So the the slope is minus PL by PK, right? The slope of the isocost curve. So if again going back to the marginal rate of substitution, and how much, if I increase 1 unit of labor, how many capital I am sacrificing. So that is the rate of change between labor and capital, and slope of isocost should be the same thing, but given as that PL by PK, that is the price of labor divided by the price of capital, because over here this is my slope and this is a constant. The budget is constant, the price remaining constant, only the labor and capital is varying. So if the labor increases or changes, how much change will take place in capital, and that is determined by this coefficient, and this is nothing but the slope. That is the ratio between price of labor and price of capital. Yes, and the vertical intercepts are nothing but cost divided by PL, price of labor. That will be my x-axis, where labor is mentioned, the quantity of labor, the amount of labor, and cost divided by PK, price of capital, will be my y-axis, that is the amount of capital, if there is no labor. And C by PL, that vertical intercept on x-axis, is nothing but, I mean, the over here this should be the vertical intercept and this should be the horizontal intercept. So over here, if there is no capital being used, this will be C by PL. If there is no labor used, this will be the C by PK. Taking this example, you can see here on the x-axis the labor curve, on the horizontal thing, we see that C by PL is the intercept. Over here C by PK is the intercept. And how do I get that? If the budget is rupees 10,000, the outlay is 10,000, labor cost is 10 per unit, capital cost is 100 per unit. Hence, how many labor I can use if there is no capital? 10,000 by 10, that is, that is 100 units, and or 1,000 units, sorry, and 10,000 by 100, that is 100 units. If there is no labor, I can employ total 100 capital units of capital if I am using that entire outlay or budget. Over here, same thing. I am not recruiting any capital. I am just recruiting labor, and I can recruit 1,000 units of labor, each taking 10 rupees, and then my total budget is exhausted at 10,000 rupees. And the slope is given as price of labor by price of K. So 10 by 100. Actually, this graph should be like this, 100 by 1,000, something like this, much more flatter, but we can't give it like now. It is like this, and it should be like this because the x-axis 1,000 should go far away, right? And now if you look at this, that maximizing output for a given cost level, you can see here that at point A and B, I am utilizing the entire budget, but I am not basically producing the maximum because my isoquant is lower, Q1, and if I am on point E, then I am achieving the highest isoquant and spending the same budget. I'm on the same isocost line, but I can achieve a higher production. So this will be the optimum one on point E. However, I cannot achieve Q3 or Q4 because that is beyond my financial capacity. My constraint is breached here, so I cannot produce Q3 and Q4. I cannot afford that capital and labor at that to produce those outputs. right? So finally we get similar to the consumer behavior, the isocost curves. Finally we get the equilibrium in indifference curve and isocost sorry, indifference curve and budget line, where they are getting being tangent to each other. That gives me the equilibrium in consumer behavior. I repeat, in consumer behavior, the consumer satisfaction is highest consuming two commodities is when the indifference curve and the budget line is being tangent to each other. And over here we observe that we are achieving the maximum production where the isoquant and the isocost curve are tangent to each other. And the isoquant, we have already learned, the slope is marginal productivity of labor divided by marginal productivity of capital, and the slope of the isocost is price of labor divided by price of capital. And you see in both the cases there is a negative sign because they are negatively sloped, and on the tangency both the slopes should be similar, and hence marginal productivity of labor divided by marginal productivity of capital should be equal to PL by PK. And then we finally derive an equation where marginal productivity of labor divided by price of labor is equals to marginal productivity of capital divided by price of capital, which marginal productivity divided by the price of labor. That means whatever I'm spending for 1 unit of labor, yes, my average marginal product or the marginal product per rupee per currency unit spent for any unit, any input should be same. Now it's labor and capital, there can be several other inputs. So for all the inputs, whatever price I'm spending per unit price, whatever marginal product the return I'm getting should be similar. So then we can achieve the equilibrium. Again, I repeat, the marginal product derived for marginal product for any input derived from 1 unit of currency spent for that particular input of production should be equal for all these inputs. Then we can achieve the equilibrium. All right, so we'll stop our class over here, and I thank you for attending this lecture. I thank you all on behalf of Swayam Broker Channel 15 for attending this lecture. Take care, stay safe. In the next lecture, we will also again continue with theory of firm, and we will be discussing theory of cost there. And till then, stay happy. Bye bye. See you.